Hi there, this is your host, hang on a sec. Hi there, this is your host Joshua here. I'm going to be joined shortly by Simon, by Cheryl, by Talisa and by Louis to find out which of these expressions has the x factor. Right, is it x squared plus 3? Well, let's have a listen. Nothing. Well, x squared plus 3 doesn't actually factorise, so I guess it's not that surprising. What about x squared minus 4x? Does that have the x factor? Well, let's have a listen.
On the first day of Christmas, my true love gave to me a partridge in a pear tree.
Right, that's enough of that. Quite good singing. Good singing, I guess. So I guess it does have the x factor. Let's see how it factorises. So x is a common factor of both terms, so we can take that outside a bracket. What needs to go inside the bracket though? Well, to get x squared you would need x times x. And to get minus 4x you would need x times minus 4. So this is how it factorises. X is a factor. Right, what about x squared plus 8x plus 15? Does that have the x factor? Well, let's have a listen. What the hell was that? Right, that definitely doesn't have the x factor. But it does factorise. This is the sort we were doing last lesson. Let's see how it factorises. So it's a quadratic with 3 terms. That means if it factorises, it goes to a double bracket. So I'm just going to draw the double brackets. To get x squared, you would need x and x at the start of each bracket. X times x is x squared. Everything's positive here. So the 2 numbers in the brackets are both positive. Put the signs in straight away. We're looking for a pair of numbers with a product of 15, but they've also got to add up to 8. So which pair has a product of 15 and also has a total of 8? Well, it's got to be 3 and 5. 3 and 5. That should be correct. Let's just check we get 8x when we expand the brackets. So 3 times x is 3x, x times 5 is 5x, 3x plus 5x is 8x. So this is correct. X plus 3 times x plus 5. Right, let's get on with the lesson. Let's get on with the lesson. Right, Factorising Quadratics Lesson 2. It's probably a good idea to have watched Lesson 1 first, because I'm going to be using the method I showed you in that lesson to do some slightly harder factorising. Last lesson we were looking at expressions that started with just x squared, whereas today we're going to be factorising quadratics that have a number in front of x squared, like 2x squared or 3x squared. So in other words, where the coefficient of x squared, the number here isn't 1. It's going to be more than 1. Right, here's the first example. 2x squared plus 9x plus 4. So we have a quadratic here with 3 terms. That means if it factorises, it must go to a double bracket. So I'll just draw the double brackets. Right, to get 2x squared, what do we need at the start of each bracket? Well, this time x and x won't work because x times x is x squared. So what we need here is 2x and x. 2x in one bracket and x in the other bracket. 2x times x is 2x squared. Now everything's positive on this side, which means that the numbers in the brackets must both be positive numbers. So since we know they're both positive, I'll put the signs in straight away, plus and plus. And the 2 numbers need to have a product of 4. So let's list the possible pairs. Could be 1 and 4, or could be 2 and 2. They're the only possibilities. Now we've got 9x here, so we need to choose a pair so that if we were to expand the brackets we'd get 9x. Now when you expand double brackets you get the x terms by doing this multiplication and this multiplication. So the inside and outside products. Now if you watched the last video I did on factorising quadratics, you're probably thinking to yourself, well, to get 9x we need to choose a pair with a total of 9. And that's almost correct. The only difference is here we've got 2x here, which changes things slightly. It means that whatever number we put here, if we were to expand the brackets, it would get multiplied with 2x. So it would be effectively doubled. So we're actually looking for a pair with a total of 9 when you double one of the numbers. So which pair, when one of the numbers is doubled, has a total of 9? Well, if you look at 1 and 4, if you double 4, you get 8. And 1 plus 8 is 9. So that should work. As long as the 4 goes here, so that it would get multiplied with the 2x and get doubled, the 1 needs to go here. That should be correct. Let's just check we do get 9x when we expand the brackets. 1 times x is 1x, 2x times 4 is 8x, 1x plus 8x is 9x. So it works. So this is correct. 2x plus 1 times x plus 4. Right, let's do another example. 3x squared plus 19x plus 20. So it's a 3-term quadratic, so it goes to a double bracket, as always. Right, to get 3x squared this time, what needs to be at the start of each bracket? Well, it's 3x and x. So 3x in one bracket, x in the other bracket. It doesn't actually matter which way around you have them at this stage. Everything's positive on this side, so the numbers in the brackets are both positive. If you had a negative number in the brackets and expanded it, you get negative terms, and there are no negative terms here, so we know both numbers must be positive. So I'll put the plus signs in there. Now we're looking for two numbers with a product of 20. So let's list the possible pairs. Could be 1 and 20, or could be 2 and 10, or 4 and 5. Those are the three possible pairs. We have 19x here. So we're kind of looking for a pair with a total of 19. But remember, whichever number we put here, if you were to expand the brackets, it would get multiplied with 3x. So it would get tripled effectively. So we're looking for a pair of numbers with a total of 19 when one of the numbers is tripled. So which pair, when you triple one of the numbers, is the total 19? Just give you a moment to think about it. Actually, I won't. You can pause the video. Well, if you focus on 4 and 5, if you triple 5, you get 15. And then 4 and 15 adds up to 19, so that should work. Provided, of course, we put the 5 here, so that it gets multiplied with 3x, so it gets tripled. The 4 here. That should be it. Let's just check we do get 19x when we do the expansion. 4 times x is 4x, 3x times 5 is 15x, 4x plus 15x is 19x. So this is correct. 3x plus 4 times x plus 5. Right, let's do a couple of examples now with minus signs in them. So 2x squared plus 7x minus 4. So double brackets as usual. To get 2x squared, we need 2x and x at the start of each bracket. 2x times x is 2x squared. And here we're looking for a pair of numbers with a product of minus 4, a negative number. That means the numbers in the brackets must have different signs this time. To have a negative product, one of the numbers has got to be positive and one of the numbers has got to be negative. So because we've got a negative number here, it means the numbers in the brackets must have different signs this time. Different signs. Now, if you remember from last lesson, if the signs are different, I ignore them for now. I only deal with them at the end. So for now, I'm just going to focus on finding pairs of numbers with a product of 4, and then I'll work out what the signs need to be at the very end. So pairs of numbers with a product of 4. Again, it's just going to be either 1 and 4, or 2 and 2. Now we have 7x here. Because the signs are different this time, we kind of need a pair with a difference of 7 to get 7x. Remember, if the signs are different, it's the difference we're interested in, not the total. So because we've got 7x here, we kind of need a pair with a difference of 7, but whichever number we put here would be effectively doubled if you were to expand the brackets, because it would get multiplied with the 2x. So we actually need to find a pair of numbers with a difference of 7 when one of the numbers is doubled. So which pair, when one of the numbers is doubled, has a difference of 7? Well, if you focus on 1 and 4, if you double 4, you get 8. And 1 and 8 do have a difference of 7. So that should work, as long as the 4 goes in this bracket, so that it would get multiplied with the 2x, so that it would get doubled if you were to expand the brackets. And the 1 here. So now we've got to decide which one's positive, which one's negative. Is it plus 1 and minus 4, or is it minus 1 and plus 4? Well, at the moment, without signs, we've got 1x here and 8x here. 2x times 4 is 8x. We want the two things here to add up to 7x. So which one would need to be positive and which one would need to be negative for them to have a total of positive 7x? Well, for them to have a positive total, the bigger one needs to be positive and the smaller one needs to be negative. So it needs to be this way round. So we need minus 1 to give us minus 1x, plus 4 to give us 8x, and then minus 1x plus 8x is 7x. So this is correct. 2x minus 1 times x plus 4. Right, let's just do another example. 3x squared minus 16x minus 12. So again, double brackets. To get 3x squared this time, we need 3x and x at the start of each bracket. 3x times x is 3x squared. And again, we've got a negative number here, which again means the numbers in the brackets will have different signs. For the numbers in the brackets to have a negative product, they must have different signs. One's going to be positive and one's going to be negative. So I'll just write that again, different signs. Now, as usual, when the signs are different, I'm going to ignore the signs. I'm just going to look for pairs of numbers with a product of 12, and I'll work out what the signs need to be at the very end. So pairs of numbers with a product of 12 are 1 and 12, 2 and 6, or 3 and 4. We have minus 16x here. So this time we're kind of looking for a pair with a difference of 16. Remember, if the signs are different, it's the difference we're interested in, not the total. So we're kind of looking for a pair with a difference of 16. But whichever number we put here would be effectively tripled, multiplied by 3, if you were to expand the brackets, because it would get multiplied with the 3x. So what we're actually looking for is a pair of numbers with a difference of 16 when one of the numbers is tripled. So which pair, when one of the numbers is tripled, multiplied by 3, has a difference of 16? Well, if you focus on the middle pair, 2 and 6, if you triple 6, you get 18. And 2 and 18 do have a difference of 16, so that should work. As long as we put the 6 here, so that it will get tripled if you were to expand the brackets, and the 2 here. Right, now we've got to decide on the signs. One of them's positive, one of them's negative. At the moment we've just got, without signs, we've just got 2x here and 18x here. 3x times 6 is 18x. We're trying to make minus 16x when we add these up. So which one would need to be positive and which one would need to be negative for them to have a total of minus 16x? Well, for them to have a negative total, this time the bigger one needs to be negative and the smaller one needs to be positive. So it needs to be this way round this time. So we need plus 2 to give us 2x and minus 6 to give us minus 18x. And then 2x minus 18x is minus 16x overall. So this is correct. 3x plus 2 times x minus 6. Right, let's do a couple more examples with minus signs now. These next two are going to be a bit different from the last two. So 2x squared minus 13x plus 20. So double brackets as always. To get 2x squared we need 2x and x in the brackets. And this time we're looking for two numbers with a product of 20, a positive number. That means the numbers in the brackets are either both positive or both negative, but they've got to have the same signs. So for the two numbers in the brackets to have a positive product, they've got to have the same signs, either both positive or both negative. So they've got the same signs this time. Now if you remember the last lesson, if the signs are the same, you can actually work out what they are straight away and put the signs in straight away. You just look at this term here. We've got minus 13x here. So the numbers in the brackets can't both be positive. Because if you were to expand the brackets, you wouldn't be able to get minus 13x. So they've got to both be negative, the two numbers. So we can put the signs in straight away, since we know now what they are. Now we can just focus on finding pairs of numbers with a product of 20. So let's list the possible pairs. Could be 1 and 20. Could be 2 and 10, or could be 4 and 5. We've got minus 13x here. So this time we're kind of looking for a pair with a total of 13. Remember, if the signs are the same, it's the total we're interested in, not the difference. So we're kind of looking for a pair with a total of 13. But whichever number we put here would be effectively doubled if you were to expand the brackets. So we're actually looking for a pair with a total of 13 when one of the numbers is doubled. So which pair, when one of the numbers is doubled, has a total of 13? Well, just focusing on the bottom pair, 4 and 5, if you double 4, you get 8. And 8 plus 5 is 13. So that should work. As long as we put the 4 here, so that it would get doubled if you were to expand the brackets, and the 5 here. So that should be correct. Let's just check we do get minus 13x when we expand the brackets. So minus 5 times x is minus 5x. 2x times minus 4 is minus 8x. Minus 5x plus minus 8x is minus 13x. So that's correct. 2x minus 5 times x minus 4. Right, let's do another example similar to that one. 5x squared minus 31x plus 6. Double brackets. Right, what do we need at the start of the brackets this time to get 5x squared? Well, it's just going to be 5x and x. 5x and x. 5x times x is 5x squared. We've got a positive number here again, which means the numbers in the brackets, again, are either both positive or both negative, but they've got to have the same signs. So again, a positive number here means the numbers in the brackets have the same signs. And as always, if the signs are the same, you can work out what the signs are straight away, just by looking at this term here. It's a negative term, which means that both numbers in the brackets must be negative numbers. They can't both be positive. So I'll put the signs in straight away. Now we can sort of forget about the signs and just focus on finding pairs of numbers with a product of 6. So pairs of numbers with a product of 6 are 1 and 6 or 2 and 3. Now we've got minus 31x here. So this time we're looking for a pair with a total of 31, kind of. Remember, if the signs are the same, it's the total we're interested in, not the difference. But whichever number we put here would be effectively multiplied by 5 if you were to expand the brackets. So we're actually looking for a pair of numbers with a total of 31 when one of the numbers is multiplied by 5. So which pair, when you multiply one of the numbers by 5, has a total of 31? Well, just focusing on the top pair, if you multiply 6 by 5, you get 30. And then 1 plus 30 is 31. So that should work, as long as we put the 6 here, so that it would get multiplied by 5 if you were to expand the brackets. And the 1 goes here. That should be the correct answer. Let's just check we do get minus 31x when we expand the brackets. So minus 1 times x is minus 1x. 5x times minus 6 is minus 30x. Minus 1x minus 30x is minus 31x. So this is correct. 5x minus 1 times x minus 6. Right, we're just going to do one more example now to finish off. A slightly harder example perhaps. Let's have a look. 4x squared plus 16x plus 15. Now what makes this one slightly harder is the fact that it starts with a 4. 4 is not a prime number, and that means that 4x squared can be split up more than one way. You'll see what I mean in a moment. The brackets could start 4x and x. 4x times x is 4x squared. So they could start that way. But there is another possibility as well. They could also start 2x and 2x. Because 2x times 2x is also 4x squared. So whenever the number here is not a prime number, the brackets could start more than one way. So if we had 6x squared or 8x squared there, we'd have the same problem. Now unfortunately there's no easy way of telling which way it's going to factorise. It can only factorise one way. It can't factorise two different ways ever. So all you can do really is you just try one way. If it works, great. If it doesn't work, you just try the other way. And that's what we're going to do. Now, whichever way it does factorise, everything's positive on this side, which means that the numbers in the brackets are going to both be positive numbers. So we'll put the signs in straight away, since we know everything's positive. We also know that the two numbers must have a product of 15. So let's list the possible pairs. Could be 1 and 15, or could be 3 and 5. They're the two possibilities. Right, let's focus on this top way, with the 4x and the x at the start of each bracket. Let's see if it factorises that way. We've got 16x here. So for this way to work, we would need to find a pair of numbers with a total of 16 when one of the numbers is multiplied by 4. And that's because whichever number we put here would effectively be multiplied by 4 if you were to expand the brackets, because it would get multiplied with the 4x. So is there a pair that when you multiply one of the numbers by 4, they add up to 16? Well, no there isn't. You could try both pairs, every possible combination. For example, with the bottom pair, let's say we multiply 3 by 4, we get 12. 12 plus 5 is 17, so that's really close. I think that's as close as you can get. But we need 16, so it's not going to work. So it doesn't factorise this way. Let's try 2x and 2x now. So remember, we're trying to get 16x when we expand the brackets. And whichever pair we choose, whichever numbers we put here, both of the numbers this time are going to be effectively doubled. Because if you were to expand the brackets, they both get multiplied with 2x. So we're looking for a pair with a total of 16 when both numbers are doubled. So is there a pair when you double both numbers, they add up to 16? Well, focusing on 3 and 5, if you double 3, you get 6, and if you double 5, you get 10. And 6 plus 10 is 16. So that should work. Let's see how that works. So 3 and 5. Of course, it doesn't matter which way round the numbers are, since the brackets both start with 2x. That should be correct. Let's just check we do get 16x when we expand the brackets. 3 times 2x is 6x. 2x times 5 is 10x. 6x plus 10x is 16x. So this is correct. 2x plus 3 times 2x plus 5. That's the end of the lesson. So we've now done 2 lessons on factorising quadratics. I now have a question for everyone watching, both of you. What's the best way to improve at maths? What's that? Watching my videos? Obviously. Apart from that. That's right, try and practice questions. So I'll put a couple of practice questions at the end of the video for anyone who wants to try. I've also put the answers after that, so you can pause the video, try the questions, and then look at the answers in that order. Right, here are the questions. Bye.